Hi everyone, and welcome to the fourth and final video going through some past exam questions on the topic of intermolecular forces. In this first question, we're looking at ICl compared to Cl2, and it says that ICl has a higher boiling point. So we need to explain in terms of intermolecular forces why it has a higher boiling point. Okay, so we want to look at what type of intermolecular forces are we talking about. Here we've got two different elements. There is going to be a difference in electronegativity here. Okay, chlorine is significantly more electronegative than iodine. Okay, so ICl molecules have permanent dipole-dipole interactions, and they are stronger than in Cl2. We're only going to have London forces because there's going to be no difference in electronegativity between chlorine and chlorine. Stronger than the London forces between Cl2 molecules, and therefore require more energy to overcome. Okay. Then it says the only intermolecular forces in solid sulfur are van der Waals forces. We've said this before. It won't use the phrase van der Waals forces. It will say London forces on the new spec. And it's then saying describe how London forces arise. This, if you've been watching the other videos, this is now the third time we've come across exactly the same question, and it's a 3-mark question again. So they are very consistent. This question comes up a lot. We've got to make sure we can do it. Let's just do this very quickly. It's going to be uneven distribution of electrons. Okay, because those electrons are constantly moving, it's going to be, this creates a temporary dipole. And then that temporary dipole induces a dipole in the neighboring molecule. So it's another one of those questions where you can be completely prepared for it. You know what you're going to need to say. So that's one of those non-negotiable questions. Make sure you know how to do that question. It is very likely that it will come up. So just why there are no other intermolecular forces. So why is it that we only have London forces in sulfur? Well, it's because there's going to be no difference in electronegativity. Okay. There's no difference in electronegativity between the atoms. So there are no dipoles. Okay. What have we got going on here? Here we've got ammonia and water showing hydrogen bonding, and it wants us to draw a labeled diagram to show the hydrogen bonding. Again, we've seen this question before. We've seen water hydrogen bonding, I think, twice already in the other videos, and we've seen NH3 hydrogen bonding once before. So again, these types of questions do come up quite a lot. So let's draw our NH3 molecule. Let's draw it with the right shape. They wouldn't mark you down for that on this particular question, but we know it looks like this kind of a shape, so we might as well try to draw it like that. We want to show our lone pair, and then that's going to bond to the hydrogen atoms of another NH3 molecule. And we want to show the lone pair there. So we're going to have our hydrogen bond here. It's always a good idea to label it. And we definitely want to show the dipoles, that the nitrogen is more electronegative than the hydrogens. Okay. It then says water has several anomalous properties as a result of its hydrogen bonding. Describe and explain one anomalous property. Okay, so we've got two options here really. We either have the fact that the ice is less dense than water and therefore floats because the hydrogen bonds hold the molecules further apart, or we'll go for the one I'll go for is that this is properties of water. So we can say water has a higher boiling point than other similar molecules. Because hydrogen bonds are relatively strong intermolecular forces. Okay, moving on. Last question I want to look at here. Fluorine is a gas and it has a very low boiling point. Draw a dot and cross diagram of fluorine. Okay, so this is something we haven't seen for a while, but there's only 1 mark, so a nice easy example. So we've just got our 2 fluorines, they're going to bond, normal single bond, and then fill in the rest of the electrons. That's quite a nice easy question for 1 mark. And then why does it have a low boiling point? This looks a bit like a GCSE question, really, but we want to show off our A-level knowledge here. You could say it's just got weak intermolecular forces, but we can do better than that. Now, what type of intermolecular force is it going to have? Well, because it's 2 of the same element, it's going to have London forces. Okay, so the London forces between the F2 molecule. So it's always a good idea to just make it clear that it's an intermolecular force. Okay, we could just say the London forces are weak, but let's say the London forces between the molecules, just to make that clear, are weak. And then we've been saying this all the way along. We can add this for an extra mark and don't take much energy to overcome. Okay, so hopefully we've seen that actually this topic, there's only sort of 4 or 5 different questions really, and the same types of questions keep coming up. So it's really important that we are prepared for those and we know what to do with them.